Hi, this is Hoppi VR episode number 3. In this episode, I'm going to be creating a pedal control for Hoppi and creating a network server for it. The plan for this episode is to do two main things. First of all, I want to get the network working on Hoppi, then build a server application. Then I want to build pedals that can move backwards and forwards, which are connected to the network, which then in turn connect to the network server that I'm making. They control each wheel directly and will allow me to drive the robot using my feet. Then I've got a few nice to have goals. First, I want to look at the bug where the head is defaulting when it switches on to some random direction, and then when I connect it, it moves back to it. I want to see if I can fix that. I want to fix the servo cables, these cables. While I was doing the demo, one of them came loose. Then there's a bug where it disconnects from the STM32. I want to be able to automatically reconnect or figure out what the bug is. And same thing with the motor control. I had a bug where it disconnected from there. So I want to, same story, try to fix that. I'm going to start by I need to take this off and just take a few pictures so I can do documentation. And then I'm going to start with the network application. I want to start programming the network side of Hoppi. So make a network server and add the network client to Hoppi and get that working. For me to do that, I need to set up this dev board again. I'm finished writing the basic network code for the Orange Pi and the server, the Windows server, and the Arduino that I'm going to use for the foot pedal. This one's got a network shield on the top. I've tested this connecting to the Windows server and that connecting to the Windows server. I don't have any messages passing through, but the connection works fine. So now I'm going to move on to building this into a foot pedal. The basic plan for the Arduino is to have it in the center and then have a 5-volt power supply running it, and then 2 potentiometers, which will be either side, and then I'm going to have a shaft and probably 2 bearings here, and then foot pedals. The foot pedals, I need to find the springs for them, but I'd like them to have springs. They'll have a default position, and they'll have a move forward and a move backwards. And then that will send a data stream up to the network and back down to Hoppi. Now I'm gonna start setting up the test version. I've connected this to my computer, not this power, and this is running off 5 volts off the Arduino, and here's the little screen. So I've got pedal left and pedal right, and then if I change these values, so these values are in between 1024 and 768, so that's pointing up that way. So if I point it all the way back down again, so it's almost a 360, and then that gives me values, and then the same thing on this side. Then what I'm going to do is I'm going to map it to the same values as the motor controller speed values. I think that's 1 through 16, I can't remember. As you can see, the wiring is very simple for this. And now that I've tested it, I'm happy, and I'm going to start building the pedals themselves now. I'm going to show you what I've got to work with. I found these bearings. I've got quite a few more of them. And then I found these rods, and they fit in here, not perfectly, but good enough. So I'm going to use one rod per side. I've also got this spring box I bought from AliExpress like ages ago, and these springs seem to be working quite well. And those are obviously the potentiometers, and that's the Arduino that I'm going to be using. Now I've got these scrap pieces of wood, so the first thing I want to do is test my ideas. I've got this, which is going to represent the pedal, and then this piece is just going to be the piece it's going to test on. And I want to test spring ideas. So where's the best place to put a spring, stuff like that. I might need a bigger piece than this. This is not going to work. I'm going to use this instead. This piece is quite big. And that will give me a nice enough space to mess around. To re-explain what I want to achieve, just imagine that this is the foot pedal and your foot sits here. I want your foot to stay, so when nothing is being pressed, I want it to stay in that position. It mustn't like move around like this. When you do press it, I want there to be a resistance and then to come back again, and same thing with backwards. The angles that it must go at is about 20 degrees, which is roughly there and there. So that's what I'm trying to achieve. The first idea, which is the simplest, is to have a screw in here and the spring about over there. Then when the pedal moves up to its highest position, the spring is compressed fully. And when it moves over there, then the spring will extend. And when it moves fully down, the spring will be extended like drastically. When it's stable, since there'll be a screw here and a screw here, the spring will always be extended. I'm not going to go with that idea because of that. The second idea is you have the screw in the same place. You have a ring in between the spring and the screw. When the pedal moves up here, the ring moves up as well. And when the pedal moves here, the spring is not extended and still compressed, but the ring is touching the screw. Then when you move down here, the ring will touch, and then the ring will compress to that. That's the second idea, which I'm going to try now. So then the idea is you put that over there and that over there, and then it sits roughly straight, so obviously you can, and then when you push down, that one does that, and then when you push down, that one does that. The first thing I notice is it's noisy. The third idea is to have the screw slightly more down and the spring is here, but instead of connecting to this, it's connected to a separate bar which is connected here and can move up and down. That will then hook on the screw over here. When it moves down, the bar will be forced down and the spring will extend. When it moves up, the bar won't be connected to the latch anymore, and the bar will stay here. You'll have another bar exactly in the same position, which is disconnected from the first bar, and same thing here. So that's the third idea, which I'm going to try now. The idea with this is you press down here and this just stays where it is. Now that's upside down. Would that work upside down? So this would probably be on the inside of the board. So it wouldn't have the screw coming from here. Yeah, that would still work. This is quieter. And it works upside down. What I'll do is I'll just put it on the inside now. See what it works. So that's that idea. I could do these plates on the inside, so on this side. Thinking I'm going to go with that idea. Now that I've confirmed the idea, I decided to design it in Blender. I've got the two foot pedals here side by side, and there's a bit of a gap in between here where I'm going to still add boards and stuff like that. So your one foot goes there, one foot goes there. It can rotate like that. It rotates at 20 degrees max either way, and what that does is then all the internal workings are here, these two flippers that I had, and all the nails and the screws and stuff go there. The spring goes in between this one and that one. And also I've got the spring on the outside here, where in my test I had the spring on the inside, so this will add a bit more springiness to it. The Arduino is going to go in the center here, and probably the power there. And what else? Yeah, so that just gives a basic idea. I've got the bearings here. So all the light brown parts are MDF, all the brown parts are wood, and the blue parts are 3D printed, and well, the metallic are metal, or some sort of other metal. There are bearings in there, and those are holding the bearings in. What else? Yeah, that's about it. So now to actually make this. I've started 3D printing the parts, and that's going to take a while, but for now I've cut these pieces. So those pieces go there. These are the foot pedals, and I've cut this piece. This piece is just going to fit in the middle here. Then I've still got to cut the little parts that come up on the side here, which is going to be cut from this, and little sections like that. The problem is my table saw can't really cut small sections. It can cut long accurate pieces, or large accurate pieces, which is why I did all of this on the table saws. But as soon as you get to like small blocks like this, then it's really bad. So I'm going to be trying to do the rest of these on my miter saw. Then the next problem is trying to get these holes very accurate. Also the bearings need to be exactly 22 mils, the holes. So I need to get that right as well. So these are the bearings I'm using, and there'll be one inset there, one inset there, and same thing with the outside ones. And I've got these drill bits. I've got all of these ones, but I found I've got this fourth one, which is exactly 22 mils. And if I put this over there, you can see it. Basically fits very nicely. I'm not going to drill straight into any of these pieces yet. I'm going to do just a test drill. And I want to set up some sort of jig where I can accurately always drill the same height and the same width for these two, and then the same thing for the little blocks on the edge. Yeah, so this is a tight fit. Yeah, I could maybe sand this slightly more. Well, let me try a few of these. Yeah, and okay, so what I can do is I can fiddle around with it. The next problem is trying to get these holes exactly where I want them. The idea I'm going with now to get it accurate is to clamp this on. I'll start by testing it and get it exactly where I want it. And once I've tested it and I'm happy, then take both pieces and drill it in using this. So I think I got it set right. This is just a test piece. I think I've got the hole in the right position. I do need to drill this a little bit further down and then also clean it up, but that's where the hole is. Next hole. But yes, so that's where that's going to sit. Okay, next one. Okay. Yeah. So that's the other one. Now what I need to do is cut the 6mm blocks from this piece. Okay, now what I need to do is get this set up so it can work on 6 those blocks. I think I've got it right. So let's just put this together the way it goes and see what it fits like. Okay, so that's the basic idea of where the bars go, and then these things sit on top here, and there's your foot pedal. I'm going to start making the bars, the bars or latches. There's 4 of them, and they are 15 mils long, which is exactly the same length as this, and 1 centimeter thick, which is the same as this, and then 20 mils wide, which is what I'm cutting up. Okay, so good thing I picked up on this. This is 15 mils. It's supposed to be 13 mils long. This is when I stack this over here and put it like where the hole should be, then it's sticking out. And so that definitely be a job. Anyway, I'm just going to cut them to 13 mils. That's the easy fix. Put this back here, and that's then it doesn't stick out. Perfect. So I need a 8mm hole all the way through. Next I want to work on this. I just want to screw and glue this flat on there, and same thing with the other side. I'm not going to screw and glue it onto this part just yet. I'm going to first wait till I've got everything finished, and then I'll do that. Next, I'm going to be working on the pedals. What I need to do is hold the shaft in the center, and I need 2 pegs here, which then push the bars up and down. I'm planning to use these nails. These are the biggest nails I've got. And the idea to hold these in is I want to cut a groove, which is 8 mils for this. It's say like about a mil or maybe 2 mils deep, and then grind the top of this off. I've cut these sections out on my table saw. I haven't cleaned it up or anything, but so far the nails fitting in there quite well. Let's see how this fits in. Yep, so it fits in there quite snugly. So I just got to clean this junk out and then flatten one of the sides of it, all of these. I've also, I think it's 5, I'm going to make these the same length out. On the drawing that I've got, they're slightly different because the one bar is over here and the other bar is on the slightly further out, but I'm just going to make these the same length, so if I get them mixed up then it's not a problem. I have finished 3D printing the parts I need for the bottom here. I made a mistake on this one, I made it too wide. So the next one which I'm printing now, I've cleaned it up. This one I'm just going to fill in. So the way it goes is that will go there, and then the nails go here. And same thing with this side. So what I'm going to do next is clean these 3D printed parts off. I need to fill in this one slightly, and then file down the nails and the shaft to the correct size so it fits in here nicely. Then drill small holes and screw everything in. Next, I want to cut a groove in here where it's circular like this, and where this fits through. It must be thick enough that this nail top can get through, and it must be circular in the same radius with that as a center. So the way I'm planning to do that is use my router with a bit that's bigger than the head of the nail, and then face it upside down and mount it on like probably a table or something, and then get a center which is the same as that, and then cut a section here, cut a section here, and basically do the same for that side. That's now finished. So this then, see how accurate I was with this. So it still fits through, just the nail heads are not fitting through the holes, but that's fine. I can still get that in there if I loosen this. I could probably file it down slightly. No. Yeah, so that then can move up and down like that. And that sits it. I probably should screw and glue this thing in now. I've got a problem. So you need to go like that. Problem is there's a gap there. So I can make a shim here and drill through it and then glue both sides on. That's one option. The next problem I ran into are these blocks are not 20 mils thick, they're actually 19 mils thick. So then what I do is I clamp that together like that, and then mess around with the height and stuff, and then once I got the height and everything right, then I screw. But just the clamp needs to be out of the way of the screw holes when I'm screwing it in. So I've tried to line this up as best as I can, and so and then what I want to do is put a screw there, so that's with the spacer there. So before I put this thing together, I wanted to add a shaft stopper. So I printed this little circle, and it fits in there perfectly. I made it 19, so it fits into the next one down, where the drills to 2220. And that sits in there, and that stops the shaft going through. That side's not square, so can I push it straight? This should be finished gluing now. Yeah, that's looking good. Next, what I want to work on is these ideas. I want to get this exactly grinded to where it should be. So obviously I need 2 of them, but also the plan was to have washers. I'm just gonna see if I can find some washers. So then the pedal stays flat, and you can move it like that. That's it. And then all of that mechanical crap's on the inside. So I've got this, which sits over here, and I just want to sand it off slightly. This goes in like so, and then that shaft meets with that shaft, and then I've got a 3D printed section which joins these two up. So that's basically it. So now I need to cut that to the right length. Now I've just got to make another one, and there's all the parts I'm going to be using. Some of the stuff's done already, some of the stuff isn't. So that's next. I'm not going to be recording the next one, since it's just exactly the same story. I finished the second one. It's all working now. It's not perfect, but it works, which is, I guess, good enough. So I'm going to change how I'm doing this slightly. I'm going to put that over there, and I'm going to put this over here, and it's going to go on top of this. That allows these to move freely. I don't have a big enough piece to do the top. I've got a whole lot of spare pieces here, but nothing that big. This one's almost perfect. This one almost fits. That can be the top. Then what I'll do is I'll make the bottom out of pieces like this. So then I can stick the Arduino there because it's thicker. And then the sides out of this as well. The bottom I'm going to glue and screw in. The rest I'm just going to screw in. So that allows me to take it apart. I have 3D printed this, and then I've placed a switch and 3 LEDs in there. The idea behind this is obviously switch it on and off. Once it goes on the Arduino, it will go yellow. If it comes into a critical error, it will go red. If it connects to the server, it will go green. And then if it disconnects, it'll go back orange again. That's the basic idea here. Here is the basic box. Still got all my drawings over that side, and this side's relatively clear. I'm thinking I put the Arduino there, right on the bottom, so it can get power and network from there. Then this, I either am going to put there or here. I'm thinking, but I want to put it on the top because that's where you might put your feet. So over here in the front. The problem I'm having is I want to be able to power one of these through a switch. In other words, I need to plug something in here, needs to go to the switch, come back, and then plug into here. So I can't have this right connected to the edge. But the network needs to be connected to the edge. To solve the previous issue that I mentioned with the network shield, what I did initially was try use this mini little network shield, but I found that it runs off separate drivers, and those drivers didn't work properly, so I didn't want to go with this idea. Then I came up with the idea of actually just joining the pins together with wires and keeping these boards separate. So what I need to do now is work out which pins are being used by the network shield and which aren't. This is the minimum pins required on the shield for it to work. So there's 1 pin still connected here, and there's 3 pins connected here, and power here. It's running off 3.3 volts. I need a power supply for the foot pedal. It doesn't need to be big. I've got this really old power supply. It says it's 4.9 volts. I'm just going to check it and see what happens. Yeah, that says 5.3 volts, but that's still fine. So now what I'm going to do is I'm going to test the red, green and orange, well, red, green and yellow LEDs with the resistors. I've uploaded a simple sketch to that just to blink the pins 2, 3 and 4, and then I've got this to power it on, so it powers on from the correct voltage, and I'm just going to power the 3 LEDs with the different resistors from the Arduino to make sure everything works. So that's what I'm using for the colors. This is a top view of the pedal. This is the backboard, and this is the network controller. I'm going to put the network controller upside down so I have access to the pins. I want to raise it a bit using something like this. And then what I want to do is I want to cut a hole in the back so this can fit through. I need to cut it so it fits out like that. So what I was thinking is printing a 3D little backing plate here, so you don't see all of this junk, you just see the hole. Then I also need a power connector here somewhere, and that will, so one of those, screws on. So I just need to drill a hole the right size, and then I need to solder this onto the back of the power supply that I've got, and then that's going to power it. Just going to clean this off. I've done the wiring for the potentiometers. That was the more difficult wiring to do, since I didn't want to disconnect them and then wire them up. I should have wired them up before I put them on here, but it's all good now. A bit of an update. I had to move the Arduino to the side because this was getting in the way. I then finished soldering some of these cables. I've added the resistors here for the LEDs going to the ground. I haven't added the cable here. And then I've added these cables which go to the pins 2, 3 and 4. And they reach the Arduino easily. Then I've partially soldered this together. This is the power connector which plugs in there. And this is the power plug for the Arduino, and then this cable and this cable then goes to the switch, which I haven't connected yet because I need to drill the hole through there first and then wire that. I've got the network shield in there, and I've sort of semi-tightened this. I'm just trying to mark off the position I want. So I'm going to do the same idea as I did with the last one, drill a bunch of holes, hole there, hole there, hole there in the corners, and then holes across, and then I'm going to try cut. But what I'm going to do is I'm going to mark the 2 spots there. I've connected the power up to the switch over there. So in theory, and I've also got this connected up. I just got to turn it on. So in theory, when I plug this in, the Arduino should go on. Nothing's connected to the Arduino, so it only should go on and nothing else. And yes, we get a red light. Okay, so, and if I switch it off, then it goes on, switch it off, switch it on, and it goes on. Okay, so the power switch is working and the cable's working. Okay, good. So I've run into too many problems with trying to separate the shield from the main board. It works and then it doesn't work, and then it works and then it doesn't work. It's just too inconsistent. So for now, what I'm going to do is I'm just going to keep the board attached, and I'm going to replace it so it sits something like that. I got the pots connected to the Arduino. I had to take the pots off and adjust them, and everything's looking good. So the next thing I'm going to do is I'm going to start coding the messages, and then I'll give a demo of the UI. I have managed to get the values from the pedals, and I know the mid, the forward, the backwards of each of these pedals. I know the differences now. And the max difference is 80, and it goes all the way down to 65. So the plan is to have a little buffer zone over here, which is a 5 either way. So there's going to be a little 10 buffer zone. and then to have 55 each way for the values, and if it's more than that, then I just max it up to the maximum value. So over here it would be a real value, here it would just be max, and here over there roughly it would be 0. So this is a very basic UI. I'm going to be changing this in the future. So on the top is the network server. It starts automatically and the devices are added here. This is a screen for the pedal and one for Hoppi, which I'm not currently using. And then I'll start up the pedal. So it switches on and connects. So I'm getting a green light here. So I've added a calibrate option, which will then calibrate to the center. So it will start getting values, and then it'll 565 and 542 are the calibrated values. So then what it does is, I was going to have a little buffer zone of 5 either way and 55, but I've changed that to 15 either way and 45. And then if I click start, I'll start getting values, and then going forward, maximum of 45, backwards, maximum of 45, and then it changes the forward, and 45 and backwards, and see the color. So this, I think it's sticking over here, but I'm still getting like non-center values. But it is, you can see if I move it like that, move my foot there, it doesn't do anything, but then it goes forward. So there's quite a big buffer zone. So this means this one's sticking quite a bit. But that's something I'll just sort out in going forward. But yeah, so that's how it works. So the next idea is I want to get Hoppi then attached to the network, and then convert these values into Hoppi motor values, and then it's send it down to Hoppi, and then in theory I should be able to control Hoppi. I've set up Hoppi on a wooden block. All the servers are still disconnected. I've just connected up the motor control. I'm going to connect this up directly to the power, so disconnect the batteries, and then I'm going to connect up the network as well. In other words, not going through the Wi-Fi. So I've got Hoppi set up here next to me. I've updated the code and compiled it. I've updated this slightly so it now has got a Hoppi which can connect to. I'm going to switch on the controller. Hoppi's already switched on. Hoppi is connected and the pedal is connected. So I'm going to calibrate the pedal, and then I'm going to start the pedal. So that's forwards. Okay, that's the right pedal. Oh, wait a minute. Yeah, that's forwards. What am I saying this back? That's correct. Yeah, that's also forwards. Okay, so that's fine. I'm going to be testing the pedals with the Hoppi on the Wi-Fi and the batteries now. I've just got this stupid little stool here and the pedals. So I'll be facing that direction towards Hoppi, and then I'll be controlling it from here. So I still need to just switch everything on and get everything connected. So this is the pedal. All you do is you switch it on, and you get 3 LEDs that go on, then you get 1, and then you get green. Now green means it's connected. So I currently got the server running. Now I need to remote to Hoppi and just get Hoppi started. I'm going to jump on the chair. I've never driven a tank before, so this should be interesting. Turning that around. Wait, up. Okay. Both work. No? Okay, I'm trying to get my bearings straight. Wait. So that's turning that way. Okay, if I go backwards with both. wanted to turn that. Oh god, this is gonna take a lot of getting used to. Okay, I want to go forward and turn. Let's try this slow. I want to go It's going to take quite a bit of getting used to. I think what's confusing me is the. So if I go forward with this one, no wait, what do you think? Go backwards. This one to go faster, so turn that one. And go left. And go left. I guess you could get used to it's bloody deep freezing right now. Is I need like a button on the side I can press with my foot, because I'm going to have the VR helmet on and the gloves, so I need an emergency stop. I guess I could make one of the buttons on the VR, like the triggers are going to be the claws, buttons at the back, just stop, start, or because I want a stop and then it ignores the pedals, and then it starts, and then it drives. After test driving it, I found two problems. It didn't have like an emergency stop, and it was very sensitive when I was driving. So I want to add 3 buttons. So this is the top. I want to add 1 button at the back and 2 buttons in the front. Now it'll be the same design. The inputs of these buttons will just be sent to the server. So when they switch on and off, it won't affect the pedals at all. But on the server, then I can assign these buttons to certain functions. Now this button, what I'm going to do is I'm going to assign it to a stop. So when you press at the back here, it will stop immediately, and then when you press it again, it will carry on going. These 2 buttons will be, well, they could be anything. But what I might do is I'll have modes, like different modes, and then on the screen it will be able to tell me which mode I'm going to. So one of the modes I have envisioned is when one of the pedals starts going forward and it gets to, say there's a gap, which will be a set variable. Say the max gap is 10. And it starts going forward and it reaches that max gap. So this is still 0 and this one's 10. Then it will go to 20. It will actually increase this value to 10. So there'll always be a maximum gap in between the 2 steering values of 10. And as you reach 36, which is the maximum Hoppi speed, the other one will be 26, even though you've let this go. And then there'll always be like a 10 gap in between the 2 pedals. I could have 2 buttons here. So what I originally was thinking is putting this board in the bottom, but now I'm thinking that will make it way easier if I put the board in at the top. So that's it so far. I've just still got to test if it works. So this is the main power. There's a little power for the 5-volt potentiometers. This is all the buttons going to the Arduino, and then this is everything connecting up. I've still got to glue this on there, but I'm going to test it first. Continuity, and then just check if it works before I glue it down. I've done a continuity check and I've checked that the buttons work, so that's all good now. Now it's to glue this on, and then I'm going to plug it in and start writing some code. Okay, so it started. Let's switch it on. No, is it on? Yes. Okay, so I'm getting LEDs and I'm connected. There we go. Then I've got button 1, button 2, button 3, button 4. And nothing. Okay, I know these buttons actually work. Don't I have to start it? Ah, there we go. Okay. So it only sends up the messages when it's sending up the messages. It's only, what's it doing now? So when I've started it, then it only detects the buttons. Is that a problem? Okay, so that's button 1. So that's button 2. So button 1 is this. Button 1, button 2, button 3, button 4. Okay, so 1, 2, 3, 4. Okay, all the buttons are working. Is that a problem? Yes, I don't. I'm gonna have to fix it because what I want is one of these buttons to stop and start the thing. So it acts as a handbrake. So I can't exactly have that button stop. Yeah. Okay. So I need to modify that code on the Arduino, but the buttons are working. So good. All good. I'm going to be trying the robot outside now. The road is a lot more rough here. It's really made for driving inside, but I just want to try it out and see what happens. Yes, you can hear when Hoppi's driving, it's really rough. So I'm going to probably keep this robot on the inside all the time. So the putty session disconnected now. I'll just have to go and try fix it. This is one of the, I think this is the major issue I'm having, is these putty sessions disconnecting. Since I'm running Hoppi within a session, what I'm going to be doing later on is running Hoppi with as a service. So it's all put together now, and there's 4 buttons on the top. And I've explained all the buttons. Those 2 right now are set to stop, and those 2 are change mode. I've just got these swapped around. So this increases mode, that decreases mode. So there's 3 modes right now. There's a normal mode, which you've already seen. There's a slow mode, which is instead of 1 to 32, it's 1 to 16. And there's a fast mode, which is 16 to 32. Okay, so this is much easier to control. Really want to do fast mode in here. Okay, that should be fast mode. So, as you can see, it's much. And then that should be normal mode. And yeah, that's back to what it was driving. I hope you've enjoyed this episode, and thanks for watching, and goodbye.